Welcome, everyone, and thank you for joining us today. My name is Jennifer Dennis, Executive Assistant here at Hamilton NG911, and I am pleased to be moderating today's webinar. The emergency services industry faces its largest challenge in decades, upgrading a 911 system to accommodate the public's reliance on mobile devices. Real-time text, or RTT, serves as a key piece to modernizing 911 access. Making the transition to RTT and 911 is presented by Toni Dunne and Jeff Knighton of the Hamilton NG911 team. Jeff and Toni have been real-time text conversation leaders. In the past year alone, Toni and Jeff have presented on RTT at over a dozen state-level emergency service conferences, the Federal Communications Commission Education Day, sat on panels for the NG911 Institute, and so much more. Hamilton believes strongly in the innovative solution of RTT, and this webinar serves as an educational piece. If you have questions during the presentation, please type them into the question box in the control panel, and we will revisit those and take additional questions at the end. Just a brief introduction to who we are. Hamilton NG911 is a leading provider of next-generation 911 core services that allow emergency communications networks to accommodate modern communication methods. Hamilton NG911 is a division of Hamilton Telecommunications. Interestingly, Hamilton was founded in 1901 and today has 8 primary company divisions that provide telecommunications and technology solutions on a local, regional, and national basis. Hamilton provides contracted traditional relay and captioned telephone services in 18 states and provides many of our services nationwide. So let's get started with the information that most directly affects you. Today's panelists are Toni Dunne and Jeff Knighton. Toni is the National Account Manager for Hamilton NG911, and Jeff Knighton is the Lead Solutions Engineer for Hamilton NG911. Toni and Jeff bring a combined 49 years of industry experience to today's webinar. Thanks for being here today, and I'll let you guys take it from here.
Thank you, Jennifer, and to everyone for joining the webinar today. We're really excited to be able to share some of this important information for 911. But before we get started, Jeff and I would like to give you just a little bit of background on ourselves. I started my career in public safety on the government side before moving to the private sector. And I've been an advocate for equal access to 911 since the early days of the ADA when it was signed into law. I've served on state chapters and national boards and a variety of committees in public safety, including those that address technical and operational issues with TTY first, then SMS, and now real-time text. Currently, I'm co-chairing the NENA RTT work group, and we're looking at all of the issues that PSAPs will be facing with this new technology.
And this is Jeff Knighton. So just by way of background, I have been involved in telecommunications since the early 1990s, and with communication involving accessibility technology since the late 1990s. And so I have been involved in real-time text effectively since its beginnings in the early 2000s, and have been involved with solutions, develop and design solutions for telecommunication relay services, as well as business telephone systems, and working on issues surrounding accessibility needs and real-time text. I presented at a number of locations. I've done quite a bit presenting at the FCC and other venues surrounding accessibility technology, and again, have been on a number of panels talking about this particular topic of real-time text.
Thanks, Jeff. Okay, well, some of you may have already heard about real-time text technology, also known as RTT, but for those of you who this is a new subject, we are going to take a look at what real-time text is. We'll look at the FCC ruling on real-time text, the impact that it has on our deaf and hard of hearing citizens, as well as what impacts there may be on PSAPs. And then we'll also take a look at the implementation of real-time text and what steps need to be made to make it to a reality. So what is real-time text? It is a new technology that is a voice call with a text component. It allows text to be sent immediately as it's created through wireless handsets and then carried over the carrier's IP networks that support real-time text. With real-time text, or RTT, there's no need to press a send key like there generally is for SMS, chat, or other types of texting. It provides a more conversational text platform and allows the recipient to be able to read the message while the sender is typing, and vice versa, to be able to type at the same time that you're reading the message that's coming in. So because of that, it becomes more conversational in nature, like we have with voice communications, voice conversations. And so this is very important for when calls will be placed to 911.
And just to add, it certainly has a role in accessibility in enabling folks that are deaf or otherwise reliant upon text-based communications, enabling them to have equal access to telecommunication services, including 911 service.
So RTT is a successor to the old technology of TTYs, and wireless providers and manufacturers of wireless handsets which are required to support TTY technology can now move away to the newer technology and provide RTT in lieu of TTY. So RTT is not designed to work on wireline calls. It is a wireless call that uses RTT on it.
And that maybe segues to the next slide on the FCC and their requirements. And I want to clarify something, that real-time text, and this is partly on the FCC side we'll get to in a second, but real-time text is something that is applicable to IP-based networks, so internet protocol-based networks. It does not work on legacy circuit switched technologies, which is predominantly what telecommunications has used in the past. So things like landlines to your home, real-time text doesn't work. But on your mobile device that is a 4G LTE mobile phone, that certainly does work because the network is an internet protocol-based network. And we'll get to that a little bit later, but let's talk through on the FCC side a little bit.
Okay. So the FCC realized that there's still some usage of TTYs out there, but more and more people are going mobile, as we all know. And so with that, the carriers actually asked the FCC if it would be permissible, instead of supporting TTY on wireless phones, to support RTT instead. And so in the 2016 report and order from the FCC, it did provide the allowance for these carriers to start supporting RTT, but they also required the carriers to make the RTT backward compatible to TTYs until such time a PSAP can receive RTT to RTT directly. So what you see here on the slide are the FCC deadlines for being in compliance with providing RTT. On the slide, you see their voluntary requirements, and you'll see on the left-hand side, Tier 1 carriers have already had some deadlines that have passed, and they've met those deadlines. Back in 2017, they were to have an app, or they were able to provide RTT natively on one phone. And we'll talk about those carriers in a bit, but they did that, and now in 2018, the deadline has passed, and the carriers are providing RTT on all new phones where there is service available. And then coming up at the end of this year, they'll have RTT on all phones. Other providers have a little bit longer to be able to do this. So by 2021, all carriers will have RTT on all new phones. So the FCC allowed them to determine how they were going to provide RTT on these handsets. And so we'll take a look a little bit later on what those look like to the citizens. And just know that also under the Tier 1 carriers, the big four, which is Verizon, AT&T, T-Mobile, and Sprint, only 3 of those carriers opted in to provide RTT. Sprint was the only one that opted out of it at this time, but they may be looking at it in the future.
And one thing that's probably helpful, at least it was helpful for me to understand, is that there is a jurisdiction that the FCC has, and there's a jurisdiction that other government agencies have. And for emergency services 911, the FCC doesn't really have any direct jurisdiction over 911. That is that's more regulated by the Department of Justice. The FCC has regulation over wireless carriers and wireline carriers. So they get to decide the regulations on the carriers. And so as part of that, you'll see on these FCC requirements, there's no obligation listed here that PSAPs have to do something by any particular time to support RTT. And it's really because the FCC doesn't have jurisdiction over it. Now, one thing that is important with respect to delivering real-time text to 911, and Toni talked about it briefly, but I want to reiterate it, that these wireless carriers, as they deploy real-time text on their networks between their handsets and their networks, they are required to convert that to be backwards compatible with TTY service, which was the previous standard. So if a person is has an RTT phone and makes a call to 911, which is something that could occur today, that call would be delivered and it would go to the correct PSAP and be converted to a TTY call, which the PSAP has the ability to support already. So the PSAPs really don't have to do anything today to start to continue to receive some calls that include now this real-time text, even though you lose a lot of the benefits of the real-time text. But we'll get to that maybe on our next slide here. Talk through.
Okay. Just a couple more things too. The FCC did require the carriers to notify their customers that their IP-based wireless services will not support TTY technology for 911 calls. Sorry, let me rephrase that. So they're requiring the wireless carriers to notify their customers about RTT. So if you go to any of their websites and type in an inquiry for our real-time text, you should be brought to a page that gives a little bit more detail on what that wireless carrier is doing with RTT. And it will also include possibly a list of phones that they're providing RTT on today. And they're also required to report back to the FCC. But like Jeff said, for PSAPs, Department of Justice is the federal agency that has oversight to 911 services. And it's important to note that while Department of Justice has not changed their language in the mandates under the ADA, they did provide a letter to the FCC that supported RTT and said that RTT met the mandates of equal and equitable level of service for people who use special technologies. So the Department of Justice does seem to view that RTT is an accessible technology that PSAPs need to be looking at implementing. So this is a good reason why we need to learn about RTT today and what's happening today. So the next slide, you'll notice that we've got why is RTT important to consumers, PSAPs, and technology. So for consumers, from that perspective, the deaf and hard of hearing consumers have expressed enthusiasm for RTT because many have stopped using TTYs and moved on to newer technologies such as this. And they want the ability to be mobile just like all other citizens, and they want to have they don't want to have to carry additional equipment in order for them to connect to a wireless phone and be able to make phone calls. So not having to carry around an extra device such as the TTY is very freeing, and the gatekeepers and leadership in the community really do support using real-time text. And because a lot of them are no longer using the TTY, there's been a little bit of a gap in reaching 911 directly. With RTT, this gives them a way to connect to 911 again without having additional TTY equipment. Interestingly, I worked with Richard Ray, who is the co-chair of the NENA Accessibility Committee, and we did some testing with each other to see how it worked. And he was very pleased with the results. He then went on to do some testing with Relay and to his 911 center. And it worked just as it was supposed to. And what do I mean by that? It converted to TTY, because that's what we're seeing the process today. And he was able to establish communications with 911 and carry on a conversation via the TTY mode at that point. So with that, go ahead, Jeff.
Oh, I was going to say some of the other aspects from the consumer standpoint that are worth highlighting. Number one, for the deaf and hard of hearing, the real-time text communication experience is a dramatic improvement over the experience using TTYs. If anyone has ever used a TTY before, then they recognize that the communication is slow. You can type faster than what TTYs can transmit text. And there's a number of other limitations with TTYs. They have to take turns. You can't, you can't send in both upper and lowercase characters. There's a very limited character set. So there's a number of inherent limitations with TTY communications. It was never, it was never designed to be the best protocol that the deaf and hard of hearing community could use. And real-time text has addressed all of those. In fact, the people that were the authors of real-time text were very, very close to the deaf and hard of hearing community. And so there are a lot of features within real-time text that are tremendously more powerful than what's available with TTYs. And so that's one benefit. The other main benefit is to highlight that the fact that real-time text is just going to be a natural part of all telephones is really something that is powerfully enabling to the deaf and hard of hearing community. Because as you mentioned, no longer do they have to carry some specialized piece of equipment or use some specialized service. They can use mainstream devices and mainstream technology to communicate not just to 911, but really to anyone else that has an RTT phone. So it allows them a new level of direct access to people, which is certainly something that is the consumers are thrilled about. And it's really not just for the deaf and hard of hearing community. Again, real-time text is something that is being added to all devices, and it can be very important for people that don't need to use it just for accessibility needs, but for convenience reasons. And especially in emergency situations, that can be very valuable, that you may find yourself in a situation where it may not be prudent for you to vocally communicate with a 911 operator. but yet you still want that real-time back and forth communication. And so real-time text fills a nice gap in how we are able to communicate today for not only the deaf and hard of hearing, but also for the mainstream users that have real-time text devices.
So Jeff, you make a good point that it is mainstream, it is for everyone, and that it's extremely beneficial for those citizens who may find themselves in a dangerous situation where talking would alert to their presence, to where they are, and so they may choose to use real-time text. And because real-time text is carried over a voice path, the benefits to the PSAP are that in a end-to-end RTT to RTT world, the PSAP will be able to hear background noises, and also the texting back and forth do not produce the same Botto loud tones that come across the telephone as a TTY does. And so it can be something that could help individuals in a dangerous situation. So that is a true benefit to the PSAP as well, being able to hear what's going on, where you can't do that in a TTY world or an SMS world.
Yeah, so let's now focus a little bit on the PSAP side. So what does RTT kind of do for a PSAP? Well, the first thing is that since the wireless carriers have a requirement to support backwards compatibility to TTYs, it means that citizens are able to utilize real-time text today for emergency calls to 911. So, well, that's maybe a little bit of a difference between how real-time text has been implemented in wireless carriers and how text to 911 or text messaging to 911 has been implemented, where there is an element that in order for communication to occur, there is a need for a PSAP to set up something new, some new relationship and some new connectivity to receive text messages. But as for real-time text, you can have successful communications today without the PSAP having to put new infrastructure in place. Now, that successful communication is, of course, has some limitations because it is converted to TTY communications, but it still allows some successful communications today. Another area of interest from a PSAP is that in a real-time text call where a PSAP is able to receive a native real-time text call, that PSAP would be a next generation PSAP, and that PSAP would be, again, able to communicate both voice and text and be able to receive the call just as it's a voice call. So with the same type of location information that would accompany a voice call to 911, they're able to get that information, the same location in the same way for a real-time text call. So it really is an improvement on the, and attaches the text to what is delivered from a wireless carrier as part of a normal call. And there's really no difference between that and what a regular voice call. It also is, from the technical side, there is harmony between what the carriers are implementing for real-time text and what many PSAPs are adhering to for standards for implementing next generation 911 services. For example, the NENA I3 standards for real-time, for next generation 911 specify the use of the same flavor of real-time text as is used for wireless carriers. And so there's a lot of technical capability and compatibility enabling those systems to harmoniously work together.
And also, PSAPs are able to utilize this with voice carryover and hearing carryover needs of the callers as well. So let's take a look, if you don't mind, with RTT and the differences between that and Text-to-9-1-1 and TTY.
Yeah, so this goes to the kind of the technology aspect of real-time text. And so we've mentioned all three of these. We've mentioned TTY, we've mentioned SMS, text messaging, and real-time text. And they all have to deal with text-based communications, but there certainly are differences, and it is valuable to understand the differences. So first of all, let's look at text messaging. So SMS, short message service. The attributes of that, first of all, from a consumer standpoint, is that they compose a message and they send the message, and then at some point in the future, which is often just a few seconds, but it could be later and it could be never, the other side receives that message and then is at their leisure able to either compose a response or not. There is no voice component on an SMS interaction. There's no phone call per se. It's just, I've got a message, I'm going to send it somewhere. And so it is very much a store and forward technology that while it's very popular, it does have its own challenges when applied to emergency situations. So that's from the technology standpoint. It's a store and forward. You compose messages. There is no voice component. There's no phone call. Okay, for TTY and real-time text, both of those are conversational technologies, meaning that there is a phone call set up. So you are calling somebody else, and then that phone call is established, and during that phone call, you're able to send communication, text-based communications, and then when that phone call ends, the communication stops. So real-time text and TTY both exist only in the context of a conversation. Additionally, both TTY and real-time text have a voice component to their communications. They really do go over a phone call. Now for a TTY, when it goes over a phone call, it utilizes the voice channel as the mechanism by which text is communicated from one party to the other party. So if I have a TTY machine and I want to send you some text characters, I type them on my TTY machine, which causes a series of tones to be produced, which are transmitted over the voice channel to the other side. And then on the other side, the receiving side, there is typically some TTY equipment which is able to detect those tones and put them back into text characters for display. Now, if you just listen to those text tones, you can hear them, you can't decipher them, and they're not very pleasant to listen to. And so for TTYs, you can do voice with it, but you kind of have to take turns. You're either using it for voice or you're sending text characters, which are producing these annoying tones that sort of steal the voice channel. And again, with TTYs, you have to take turns. So if you're producing these tones, then the other side cannot be producing tones. It has to be in receive mode. So you have this, what they call half duplex communication. It's almost like a walkie-talkie, where you have to talk a little bit and then you say over, and the other side can then talk. With TTY, the convention is that you type something like a GA at the end of it, meaning go ahead. I'm done typing something, go ahead, you can start typing. And so there's a lot of limitations. Now with real-time text, it has some attributes of the same type of thing. It's in a conversation. There is a voice component, but you're able to transmit text characters silently to the other party without disrupting the voice communication that can occur. And so that enables two parties to be able to both type and talk at the same time. And there is no collision if one party starts typing and then the other side wants to interrupt them by typing something back. And so it allows full duplex communications, both on the voice side and on the text side. Now, in order to achieve this, real-time text is associated with internet-based technologies. So internet protocol technologies, which is the same technology that powers the internet with a capital I, but it is that same technology, internet protocol, that powers wireless carriers' 4G LTE networks, as well as next generation 911 systems. So from so there is an ability to do a backward compatibility between TTY and RTT. Whenever you do that, you kind of have to restrict your communication to the lowest common denominator, which is TTY, which means that your communication gets slower. With real-time text, one of the attributes of it is that you can type any character you want, upper, lower case, Japanese characters, any type of character that can be that is in the Unicode character set can be transmitted. With TTY, it's a very limited set. So there's certainly some technical challenges, and something is lost when you have to convert between the two. But they're both conversational-based technologies. All right. Anything to add, Toni?
No, just the character set is important to understand, as well as the turn taking in a 911 world. We are going to need to look at our training and SOPs, standard operating procedures, when these calls come in, because your citizen may believe that they are communicating in full RTT mode, but when it gets transcoded back to a TTY on the PSAP side, they may not understand that. They may not understand the limitations with that, and so there's going to be some need to educate the public as well as training your call takers.
That's a great point, and I think this slide is going to help us visualize maybe at least some more of those challenges. So with real-time text today, it is available on a number of mobile phone devices. And when the FCC came out with its report and order in December of 2016, they didn't regulate dramatically how the handset manufacturers had to implement real-time text. So there's a lot of flexibility that manufacturers have in terms of how they may want to present this capability of real-time text. One of the things that the FCC did mandate is that you have to always have voice available when you set up a real-time text call. You don't have to use it, but it always has to be sort of engaged. And so what we see here are two implementations from different manufacturers on how they implemented real-time text. So one of the picture on the left is an LG model. I believe it's a G6. It's the phone that I personally have. And for that phone, when you get into a real-time text call, you have a screen that is this one in green here that has bubbles. And it kind of looks like what you would expect for a text messaging user interface. One difference is that as you're composing a message, it's composing it inside the bubble. There is no send key, so it's composing it inside the bubble, and it is then being transmitted. So as the remote party is transmitting and those characters arrive, they get sort of added to the bubble, signifying from the remote party, and that's how it looks. Now, Samsung, which is the picture on the right-hand side, they took kind of a similar approach where they had bubbles for the different text, but there's one sort of subtle difference between the two, and that is in the use of the keyboard. So on the keyboard on the left, on the LG, they have specialized buttons for SK and GA, and for those with TTY training recognize that those are the sort of common combinations of characters that are sent to indicate the end of a turn or the end of a conversation. When I'm at the end of a turn, I would type GA, end of a conversation, type SK. Whereas the Samsung one's a little bit more forward, thinking that those constructs are not necessarily needed in real-time text, and so it just has a more traditional keyboard. You have the ability with real-time text to include, again, any character that these keyboards could produce, including some emojis, which brings its own challenges to how those get rendered at a PSAP, especially when they're converted from backward compatibility. So this is a couple of implementations. These are native to these specific phones. If we go to the next slide, we'll see something that AT&T chose to do. So of the 3 tier 1 carriers that implemented this real-time text, 2 of them decided to just implement it natively on devices. So Samsung implemented it natively this is for T-Mobile and Verizon. AT&T out of the gate, they decided to make real-time text available as a downloadable app that you would just install on either your iOS or your Android phones. And you would be able to then launch it to place, and these are the screens of what it looks like for the AT&T app when you download it and then you use it to make a phone call. Now the AT&T app, it uses your same phone number that is associated with the phone device, but it gives you 2 options. You can either just make a voice call or a real-time text call. If you do a real-time text call, then you get this screen on the far right-hand side, and the AT&T app chose to not use bubbles, but to use kind of a horizontal split screen so that the received text shows in the upper half, and the sent text is in the bottom one. So there's a lot of flexibility and a lot of different ways of implementing real-time text. Now there is compatibility between carriers. So if you have an AT&T phone and you call somebody that has a Verizon phone and you establish a real-time text call with them, that'll go through natively, and you'll be able to communicate with each other with that. So AT&T is now moving towards implementing some real-time text on native phones. I believe they have an implementation on iOS now that's native, but certainly different manufacturers have some flexibility on how they implement it.
So Jeff, could you, let's go to the next slide and kind of describe how these RTT calls will be routed and how the PSAPs will receive them? Yeah.
So there's a picture here, and it may be, the words may be a little bit too small, but I'm going to kind of go through this a little bit. So we just saw a picture, we just saw a couple of slides of what the consumer devices might be. And so now we're going to follow the pathway to say, okay, what happens when somebody with one of those consumer devices or the AT&T app, what happens when they dial 911? And that is represented by this picture on the top left saying RTT enabled device, sending its traffic to this antenna thing, which would be sort of the access network of the wireless carrier, or in this the CMSP, commercial mobile service provider. We like to use lots of acronyms everywhere we can. So basically the call goes to the wireless carrier. Now, the wireless carrier then has 2 choices. The wireless carrier what mostly occurs today is that those wireless carriers will deliver the call to a legacy emergency services network, which would go to a selective router. And then from the selective router, it would be then dispatched to the appropriate PSAP. Well, prior to delivering that call to the selective router, the wireless carriers engage a gateway, which is that little bluish square between the CMSP infrastructure network and the legacy emergency services network. And that gateway does a protocol conversion and converts that real-time text to TTY. So that pathway, that far left pathway, is it would be in the majority today of how calls, real-time text calls, go to a PSAP, is that it gets the wireless carrier, sends it through a gateway, which converts it to TTY. So at the point that it gets to a selective router and to the PSAP, they have no knowledge that it started out real-time text, but to them it just looks like a TTY. Okay, so that's that first pathway. The second pathway, if you go back up to the CMSP infrastructure network, that pinkish bubble, is that wireless network could be able to deliver that call to a next generation emergency services network, or ESINet or ESINet. And in that circumstance, the wireless carrier would deliver that call directly to the ESINet and the ESINet provider. When that call is delivered to the ESINet provider, the real-time text, native real-time text, would be maintained. And so at that point then, the ESINet provider has a responsibility then to deliver that to the appropriate PSAP. And for an ESINet provider, there may be two types of PSAPs, really. PSAPs that are next generation PSAPs that can support real-time text natively, or a PSAP that can't support real-time text. And so those two choices on PSAPs are at the very bottom. So the bottom on the far right is indicative of a PSAP that is a next generation PSAP that can support real-time text. And so in that pathway, the real-time text would be supported then end-to-end between the telecommunicator console and the RTT phone device. And you would have native real-time text with all the benefits of it. Well, if the ESINet network is connected to a PSAP that doesn't support real-time text, then the ESINet has a responsibility for implementing the same type of gateway functionality to convert the call from real-time text to TTY to deliver it to the legacy PSAPs. And so the main benefits here is that there is an architecture in place that enables a transition and an evolutionary support for real-time text, so that there's continuity where backwards compatibility to TTY is done if it needs to, but ideally moving forward in the future, we'll have more and more PSAPs that are next generation 911 capable and RTT capable and able to support that native real-time text.
And the architecture is standards-based, right?
Yeah, absolutely. The architectures are standards-based. There's a number of standards organizations that have worked very hard to ensure that this is compatible. So you have standards organizations like ADIS, which produces standards for the wireless carriers and what they adhere to. And you have NINA, which has standards, and also the IETF has some standards surrounding all of these technologies. And there's a lot of harmony in the protocols, so that it really should make, from an implementation standpoint, it should allow ESINet providers and wireless carriers and I3 PSAPs to propel forward without having to sort of change directions. So from a PSAP standpoint, if you're moving towards a next generation 911 PSAP, then the support for real-time text that's part of the inherent standards for next generation 911 are then compatible with the ATIS standards for delivery from the wireless carriers. Yes, all standards based.
So we've looked at what RTT is. We've found out how it is routed, but what is the PSAP going to see when these calls come in? What you are looking at right now are two screenshots that I took when I went to a PSAP, and we actually made some RTT calls to that PSAP, and you'll notice that well, the PSAPs are not RTT capable yet, and so these calls, these wireless calls, came in and were delivered as a TTY call. So it's important to note that it was a voice call, and it had all of the components of a voice call when it was delivered. So if you'll notice the class of service on either one of these screens, they differ depending upon the carrier and how they were delivering RTT. So I'm from Texas, and this was a Texas PSAP. And in our state, we do have a class of service, VMBL, which is voice mobile. Not every state will have that same class of service. More likely it's a wireless phase 2, WPH2, or VNOM. It's going to vary across the country, but it will come in as a wireless call. And just like any call, it's going to give you some coordinates. It may be your tower, it may be your phase 1, or it may be your phase 2, and then also, pop to the map. You'll notice on the left-hand side where it has the VoIP call, it shows a VoIP caller, and then on the right it's the wireless call. You can rebid these calls just like any other wireless call. And on the right, you'll notice that the TTY opened and a conversation occurred. So some will come in as a voice, and the call taker will not necessarily know it's an RTT call until they hear Botto tones or until they challenge the silent open line call and begin receiving the text communications back and forth. So it may or may not pop the TTY detection with this type of call. So PSAPs will need to do their challenging of that silent open line call if they've got silence for this wireless call. In some of the tests, the TTY call was from a Verizon iPhone, and the application automatically sent 3 characters of Botto tones so that the CPE TTY window would pop open. So I just wanted to give you just a quick snapshot of what it will look like today. We don't know what it's going to look like tomorrow, because it's our understanding that the CPE providers are working diligently to include RTT in their equipment platform, but it's likely to be similar to as we're seeing it presented today with TTY. You may have a different window that, just as in SMS has a different window that opens up, you may have a different window that opens up for RTT. We just don't have the ability to show that today. So if we go on to the next steps, what do you guys need to do to be ready to take RTT calls? I think one of the most important things is to talk to your vendors, your companies, about what their plans are to integrate RTT into their platforms. Making sure that you do still have a text to 911 solution in place as well, because one does not supplant the other. And then with the goal that RTT is making 911 directly accessible for everybody. Jeff, did I miss anything? So the driver from a regulatory standpoint is that the FCC's laid out the rulings that enables carriers to support RTT. and it also put into place a way to deliver RTT to the PSAPs. And now we have to work with the companies to make sure that they are on the roadmap to being able to provide it as well. So coordination is really going to be needed between all of your providers. And also, I just want to add that the NENA RTT Working Group is currently developing RTT operational standards. We will be developing a sample letter to request your carriers to deliver RTT when you are RTT capable. And be aware that the FCC is giving the carriers up to 6 months to deliver RTT. So as soon as you have the capability of receiving it, you write your letter, and then they are on notice to be providing it within 6 months. So it is very similar to the process that we had for SMS Text-to-9-1-1. And we're also in the working group developing a checklist for deployment. And so be on the lookout that NENA will be offering up some of these helps for you, as well as Hamilton has developed a white paper on RTT that you will be able to download. I think we'll hear a little bit more about that at the end. So I guess now we'll go to see if we have any questions.
Awesome. Thank you so much, Jeff and Toni. And we will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the question box in your control panel. And it looks like we have a few questions now. Okay, so the question indicates we go through a competitive bid process for our wireless services. Is there any type of sample language we could include in our RFP document that would compel the carriers to comply with the timeline to deliver RTT to me?
So, Jeff, do you have some suggestions?
So I do have some suggestions on this. If you go back to the FCC ruling, the FCC ruling talked about the procedure, and we touched on a little bit, the procedure, how wireless carriers are obligated to deliver native real-time text to PSAPs. And really there's a criteria that says that when a PSAP is RTT ready, then they can request RTT service, and the wireless carriers, by composing and sending this letter, and the wireless carriers have 6 months to comply. And so when you talk about language, the place where language is going to be valuable is the language to your vendors on your current system, because you have an obligation as a PSAP to sort of showcase and prove that you are capable of supporting real-time text prior to engaging the wireless carriers to deliver it. So that's where I would suggest focus on the language with respect to your vendors and your implementation to ensure that your PSAP can demonstrate native RTT support, and then use that as part of the use that before you then contact the wireless carriers.
Yes, I agree. It's very important for us to be ready before we are making that request to the carriers. Also, going back to the NENA RTT Working Group, we will have some sample letter language. But I wanted to add that I'm aware of one region that when they upgraded their CPE, their call handling equipment, or I think it's now being called CHE, when they upgraded their equipment, they added in the language of the RFP that the equipment had to be RTT capable within 6 months of request to the equipment provider. So they were allowing the RFP to be responded to if they did not yet have RTT, but it was on the roadmap for within 6 months. So that's another idea to add to your RFPs to make sure that whoever you are going to be using has the RTT capability in the future.
Okay. Another question says, are there any next-gen core providers that have received RTT and converted to TTY to non-RTT CPE PSAPs?
This is a question that we also received last week at the NENA Standards and Best Practices Conference.
So maybe there was a question to this effect. It was actually a very similar question, which was, and this was asked in one of the sessions, has any PSAP received native real-time text? And this was asked, again, at the NENA Standards and Best Practices Convention, and with a room full of 200 people from across the nation, and no one raised their hand. And so that at least is indicative that if there are instances where an ESINet provider is receiving the handoff and converting the TTY, that hasn't been made publicly known.
However, I think that there are wireless carriers that are interested in doing that testing today, and they're waiting for that ability to be able to do that.
Another question states, do we know the percentage of RTT handsets that exist today?
No. I mean, the short answer is no, we don't know that. And the better answer is that one of the reasons we don't know that is that it is continually changing. And new handsets are being added very rapidly. It is very challenging to maintain a list of handsets that support real-time text because they are, the number is increasing almost daily as new devices constantly come out. And that's why each of these providers that supports real-time text, they have information on their respective websites that talks about which devices have support for real-time text.
And we do know that by 2021 that all carriers will have RTT on all new phones. So at least there is a deadline. It's a little bit out there, but to Jeff's point, I think that the best way to know is to go to the carriers' websites and see what information they're providing.
So it looks like we've covered all the questions for today. Thank you, everyone. We appreciate your time, and be sure to click over to hamiltonng911.com for more information on our core services, new solutions like Text Connect, and much more. As Toni mentioned earlier, we do have a white paper highlighting the details and timelines surrounding RTT, and if you'd like to get your hands on that, please let us know, and we'd be happy to send it your way. And finally, we will make the recording of this webinar available for replay, and we'll send that link out to you later in the week. The email will also provide an opportunity to leave feedback. So thanks again for joining us today, and we will see you next time.